Hello and welcome to this lesson about functions. The learning target of this video is identifying functions and parts of functions. I want to start by talking about what I'm going to call the function family tree, and actually what it is it's going to be a Venn diagram. So what we have is relations, and relations are any sort of grouping of x and y's. So any grouping of x comma y's, or if you want to, you can rephrase it as inputs and outputs. So it's a set of data. Now within this is a smaller subgroup, and that is functions. And functions follow a specific rule. And that is a relation where each input goes to only one output. And so that is what defines a function. Now, what I want to do before I get any further is just kind of talk more vocab here, so other parts of this quote-unquote family tree. So one thing we're going to see, if we can, let's jot this down here, some vocab. Some words are interchangeable. So one of them is going to be input, which could also be interchanged with, oops, sorry about that, input, x values, or even domain. These all go together. And then the other one is output. It's obviously the opposite of input. And then we have y values and range. And I bring this up because what you're going to see is, depending on where you're doing some problems, like if it's on IXL, Khan Academy, a textbook, a standardized test, you could see any of these words, and they essentially mean the same thing. And I mean, there are certain times when one is more appropriate than the other, but for generally speaking, you can interchange these words and understand, like, they kind of talk about the same idea, the same concept. And so now let's talk about the rule. When it comes to functions, there are two rules. There's the rule with the capital R, and there's the rule with the lowercase r. And the one we're talking about right now is the capital R. So this is the big one. And it's really simple. It's what defines a function, which is that each input goes to only one output. All right, now that's part of the definition. But another reason why I want to bring this up is because when we talk about this graphically, there's a simpler way to do this. So on a graph, it boils down to vertical line test, which is a vertical line, and a vertical line is this, can't touch the graph twice. If it touches the graph twice, you no longer have a function and you have a relation. And so what I want to do is go over some examples. Now, when it comes to dealing with functions, we're going to see two cases. We're going to see tables and we're going to see graphs. So we'll start off with tables because they're a little more confusing. So a table, it could be given to you as x, y, or it could be given to you as input, output. And keep in mind, like, those are interchangeable. So x and input are the same, y and output are the same. And there's a subtle difference between x and y, input, output, and domain and range, and we'll get there in a second. But let's just say, we're looking at a table, and the question is, are these functions? And so we have to look at the values. And so if we have like 1, 3, 5, and let's just say 9, and 4, 5, 6, and 7. This works because the 1 is only showing up once and it's going to the 4. The 3 only shows up once and it's going to the 5. The 5 is only showing up once in the X column here, which is fine. Going to the 6, 9 goes to 7. So, yes. Now, when it's not going to be a function is where you have something like this. 1, 3, 3, 9, and then let's just say 6, 4, 2, and 0. And the reason why this is not a function is because 3 shows up twice. It's going to 4 and it's going to 3. And so this is no. And again, sometimes you might see it. You might see it like this. So input, output, 1, 3, 9, and it might be like they draw lines. So 1 goes to 6, 3 goes to 4, 3 also goes to 2, and then they'll put a 0 and draw lines like that. If you see this, again, that's the same thing as this, and it's an indicator that it is not a function. So no, it is not. And just a couple of things I want to kind of point out to you. Some situations can look tricky and are functions. Others are not functions. So again, let's just say X and Y, input, output, whatever you want to call them. And we go 1, 2, 3, 4, and we just say 4. And all of these are going to 4. This is a function because each input, each X is going to a Y. And it's not going to, it's okay that the output is going back to the same or different inputs, so that's okay. But if we had it the other way around, 4, 1, 2, 3, 4, then this is not a function. All right. Now, continuing on, actually no, we'll leave it at that. We'll talk about domain and range in a minute. Now, let's look at some graphs. Graphs use the vertical line test. And so what we have to do is take something like a ruler, pencil, whatever you have on hand, and you're going to make it vertical like that. And then you just run it along your graph. Uh-oh, it's going to go behind it. One sec. There we go. Now it's in front of it. So you just take this vertical line, and if it crosses or if your graph hits it twice, oops, it's not a function. But right here, it's only hitting it at one spot. So that leftmost part is just hitting the function at one spot, and so that's cool. That means that this is a function. So let me just jot that down. This guy is a function. All right, now let's look at another graph. Let's try this guy. So again, we take our ruler, our pencil, whatever it is, you try to put it over, and it's set so it's going to go underneath it, but you can see that it's going to cross, a vertical line crosses twice, there and there. So not a function. Failed the vertical line test. We'll do one more for good measure here. So let's take a look at this one. Here, take our vertical line and just notice that anywhere it goes, it's only crossing the graph once. So again, this one would be a function. So yes. So that's how you determine if something is a function via a graph. Now let's talk about how to find domain and range. And what you have to do is you just have to make some associations in your brain. Domain, X values, range, Y values. So if we're talking about a table, we have X, we have Y, and let's say we have 11, 12, 13, 14, and here we have 3, 5, 3, 5. This is a function because, again, each one of the X values is going to only one Y value, so that's fine. The domain is going to be, and we have several ways we can write it. Here we use a little squiggly lines, and we just write the X values. 11, 12, 13, 14. Done. For range, squiggly values, we write the Y values. 3, 5. That's it. So domain and range from a table are easy. You just take these numbers and you put them in a list. And sometimes you don't have to write them all because they double up. All right, now if we have a picture, it's a little bit different. So let's take a look at this graph. Now, the same idea applies. Domain is X, which I'm going to use for green, or I'm going to use green for it, and range is Y, which we'll still use yellow for. So what we're doing is we're looking on just the x-axis. How far on the x-axis does this graph exist? And we can see it goes from -3 to +3. And so for the domain for this one, what we're going to say is we're going to mix it up a little bit. We're going to go -3 less than or equal to x less than or equal to 3, because it's going through all those points. The last one, we were just talking about random points that were plotted. So that's why we had to be specific with numbers. But here, now we're talking about a spread. Same idea applies for the range. And so we're going to use yellow for this. So down here all the way to up there, this is -8. That's +1. So the range is from -8 less than or equal to y less than or equal to 1. And so that's why for domain and range we need to associate x and y, because when we write it out like this, we need to use the proper variable. We need to use x or we need to use y. Let's do one more example. So again, associate x for domain, and then range is y. And so for something funky like this, what we're going to see is that wrong color. There we go. For the x, it goes from here to here. So the domain, -5 less than or equal to x less than or equal to 5. Now the range, this is a funky looking graph, but we're looking at where is it at its lowest and where is it at its highest. And that's at -1 on the y-axis. That's what we care about. And this is at +1 at the y-axis. So the range is going to be -1 less than or equal to y less than or equal to, whoops, not 5, I was looking at the previous one, 1. And so that's how you find domain and range from a graph. Now, we're going to talk about finding values. So when it comes to finding values, we're going to be looking at a graph, and it's just about being able to read it. So let's take a look at this graph. And the way the sort of finding values thing works is you're going to be given, it could be phrased in a variety of different looks and ways, but essentially it's going to be, here's an x, y. I'm going to give you one of them, you got to find the other. So let's say when this function has an x value of 3, what is the y value? Or let's just say, let's get another example in here, when the function is at -10, oh no, let's not use that. Or let's say for the y value, when it's at -5, what is the x value? And so it's about reading the graph. So for this first one, let's take a look at where 3 is. So 1, 2, 3, go up here to the graph. It is at 2, done. For this one right here, -5, look at -5 on the y-axis, find that, and then it is at about 6. So that's, or -6, sorry, -6. So that's finding values. Finally, we have finding the rule. And this one is a lowercase r, not with the uppercase r. And so sometimes you can say a function is defined by, in simple terms, adding 2. And so what you could do is you could use the rule and say maybe complete the table. So here's the rule, here's an XY table, complete the table. So we have 1, 5, 9, 13. Well, the rule is you add 2. So 3, 7, 11, 15. The same thing could be, or they could say find the rule, and what you can get is maybe you get a table. So X, Y, and you have 1, 4, 7, and what we see is 2, 8, 14. And the question is, again, what is the rule? Well, here, the rule looks like we are just timesing by 2. So that's functions in a nutshell. Again, we got a lot going on here. There's a lot of components, but once you kind of figure out the vocabulary of it all, it's pretty straightforward, and it's just, a lot of pointing out math. So the vertical line test is pointing out math, not a lot of number crunching going on. Domain and range, again, just kind of pointing out, identifying, and even finding the rule, just a little bit of thinking involved there. And then that's how we this is a great introduction to functions. So good luck with your practice and homework, and let me know if you have any questions.